Well, hello everyone, and welcome to another episode with your girl, Audrey Codner from ACG Math Tutoring. Hopefully you guys are having a lovely Monday evening. I know my day has been nice and busy, so hopefully yours was as well. So what we're going to be working on tonight is called the Pythagorean Theorem. And I know a lot of you guys probably have it memorized, or you're just like, I think I remember what this was. Well, what the Pythagorean Theorem is, you're taking the sum of the squares of the two legs of a right triangle, and you're going to see if it equals the square of your longest side, which is called your hypotenuse. So if you take a look over here on the side, this is exactly what I'm talking about. A squared plus B squared equals C squared. Okay, a lot of us have it memorized and you're wondering why. All right, it all kind of came about way back in the day when we had a lot of our fishermen were just trying to figure out a way to get from one point to another so they can travel all of their spices and everything. So they came up with the Pythagorean Theorem. So they're taking the trip of one side, taking the trip of another side, and they're saying, you know what, why are we doing this? We should just do this. And how long would it take us to get from point A to point B? Okay? So you always wonder why this is out here? This is why. All right, so as you guys are coming on in, go ahead and tap the screen. We're looking at this for basically an hour. Some of it we're going to do with a little bit of naked math, and some of it we're actually going to be doing some word problems, just how to set it up, how to break it down so you can be successful in either your regular algebra class that you're taking here, or maybe your geometry class, which you're going to see this like basically second quarter. You're also taking your GED, your ASVAB, your ACCUPLACER, even the TEAS test and the HESI test. This is definitely on there. Now, if it's a GED, this is considered a 4-point question. So I tried to kind of mingle a little bit of the 3s and the 4s, but I really want you to get more of these 4-point questions so you can pass the test. All right, so as you're coming in here, hey Jess, hey Test Squared, hey Pooh, come on in and keep on tapping. I'm going to get started once we get to the 1K, because that helps a lot of people to find it on their FYP. Good evening. How's it going there, Test? Oh, thanks for the follow. All right, we're almost there. We're at 647 right now that I see on mine. So just a quick little mad tap as you guys are coming in. There's roughly 300 of us in this live. Come on, let's do it. It's going okay? Okay. All right, thank you so much for the follow, everyone. Appreciate it. All right, so now let's go with our Pythagorean Theorem. So as I mentioned here, the A and the B, those are called your legs. So here's one way to recognize it. The side that is directly across from your 90-degree angle, that is your hypotenuse. Okay, we're going to say height for short. Okay, the other two sides, these are called your legs. You got two of them. Okay, but the only difference between these two legs, they're interchangeable. We don't have to just have a left side or the right side. It doesn't matter which one of those is going to represent the A or the B. Either way, it's going to be exactly the same outcome. But as long as you know that the side that's directly across from your 90-degree angle, that's your longest side. Your longest side is called your hypotenuse. So when we go back to the formula is your A squared plus B squared equals C squared. So I'm going to make, I don't know, let's say 15 will be my A. 20 will be my b squared. And the c squared is what we're looking for. Because notice we got the question mark for the hypotenuse. So now we just need to know 15 squared. That does not mean 15 times 2. That's not 30. 15 squared means 15 times 15. So if we got our 15 times 15, that would give us our 225. Bring down our plus sign. Then 20 squared. So 20 squared again is not 20 times 2. That's 20 times 20, which gives us our 400. And that's going to equal our c squared. So now 225 plus 400, that'll give me my 625 equals your c squared. So when it comes to solving for c, we always want to do the inverse operation. So the inverse of a square is a square root. Whatever I do on one side, I have to do on the other. Because what happens is a square and the square roots, they're inverses of each other. They're going to cancel each other out. So that means this c is going to come down unscathed. But then the square root of 625, as someone mentioned a little bit earlier, hey Andy, with our 625, someone mentioned it earlier. Mella, there we go. So we have our 25 because the square root of 625, that is a perfect square root. So the number multiplied by itself is going to be 25. Because 25 times 25 gives me 625. So basically the length of my hypotenuse is going to be 25, whatever the units are. Okay. All right. Hey Janice, how are you? Feel like I just talked to you. All right. Always well. So now we have our next one. So we have one side of our legs is a 3, the other one is a 4. And I'm going to explain this one in a second because I think a lot of people will be like, oh, I know what the hypotenuse is. Boom, I already got one person put it up there. All right. So if we do continue on to the trend, we have our a squared plus b squared equals c squared. So if you're new to my platform here, I usually take things step by step. I kind of geared towards people that are just like, I hate math, or I geared towards people that I haven't seen this in forever and I really want to help my kids, or I'm currently in maybe a college algebra class, or I'm pursuing a higher grade in the GED, the ASVAB, and so forth. So I usually take my time, okay? So again, we know a leg, we know a leg. It doesn't matter which one's going to be which. So I have 3 squared plus 4 squared equals c squared. So 3 squared, that gives me 9. 4 squared, that gives me 16, because 4 times 4 gives me 16. 3 times 3 gives me 9. So bring down my c squared. So now I have like terms I can combine. So 9 plus 16, that gives me 25. And that's what c squared equals. Again, if I want to get rid of the square, I have to do the inverse, which is the square root. So the square root and the square will cancel out. So now I can bring my c down equals, And we got the square root of 25. Square root of 25 will give me 5. And I know and you know that if we come out of a square root, we usually have two forms of an answer. We usually have a positive answer and a negative answer. And sometimes you may see the symbol as a plus minus. But we're talking about a length of a side, okay? A physical length of a side. We can move things in the negative direction, but if we're talking about length, we're only going to focus on the positive answer, okay? So we're only going to focus on the positive answer. Now, the 3, 4, 5 triangle is usually the most famous when it comes to Pythagorean theorem, just to prove it. I've seen people use crackers. I've seen people use all kinds of crazy different ways to prove it and fun ways to prove it. Okay? So all you have to understand is the basis. If you can understand what a squared plus b squared equals c squared, you're going to be perfectly fine. Okay? Okay, questions so far? Yep, it is the most famous Pythagorean triple. Yes. All right. Very straightforward. I mean, it's mostly famous. Now, I'm going to give you a couple before we get to the word problems. Because like I said, this is going to be a short live. You know, people got stuff to do. Just because I'm bored to tears doesn't mean anything. I'm just kidding. So if you guys can tap while I am setting up the new situation right here before we go into our word problems, I would greatly appreciate that. And if you are thinking about getting your GED and you're just like, I don't know what program to do and should I go into a program and all this stuff? Well, I do have courses that can kind of help you out. And to see, kind of support you, especially with the algebra piece. So I have one for GED, for ACCUPLACER, and if you go to the Service Plus, all that vital information is there at your disposal. All right, so this time we're trying to prove that this is a right triangle. I shouldn't put the symbols down because we don't know if it's a right triangle, yes or no. All right, so ignore the symbols. It's just habit, it's just really habit. 1 minute, yep. Okay, awesome. So here we go. So ignore that this is here. We want to know if this triangle is a right triangle. And one of the ways that you can prove that it's a right triangle is using Pythagorean theorem. So ignore the symbol. That was my human error. Blast me for being human. All right. So again, the two legs are going to be in, say that this wasn't here. So the two of your lower numbers, they're going to be your legs. Your highest number is going to act as your C, your hypotenuse. So we want to know if the sum of the squares, so that's my 9 squared and my 10 squared, I want to know, and I'm going to put a question mark here, I want to know if the sum of these two squares is going to equal my hypotenuse. If it does, that means this triangle will be a right triangle. So for those that are coming in, this was dealt on human error. Okay, it's a crazy habit that I have. Okay, so let's take a look. All right, take basic math classes now. Awesome, Darlene, good. What's your homework? Awesome. All right, so here we go. 9 squared. What is 9 squared? Let's put it in the chat. I don't want to steal the thunder. What's 9 squared? What we got? And don't be afraid. If you're not sure, put a question mark. You can still participate. That'll be kind of cool. All right, so I'm seeing a C of 81s. We say 9 times 9. Good. We got our 81s. Okay, high. Might want to take a look. Okay, 9 squared. Good. Awesome. 9 squared is exactly the same as saying 9 times 9. Okay, 9 times 9, that gives me 81. Bring down the plus sign. Who's checking in? Hey, Jordan Square. I'm a kid. Awesome. Well, learn 9 squared. You learned something today. All right, so now 10 squared. So let's see if you can redeem yourself, kid. 10 squared. We've got a whole bunch of hundred funds. MJ, Rosette, yeah, Shakira, yay. Been seeing a couple days. There you go, hi. See, you're not too much of a kid. There we are. Good, Jordan Squared. Good, test. Good, Flacco, good. So this gives me, because this is 10 times 10. That gives me 100. Now, here's the tricky one. What's 16 squared? And don't say 32. Okay, good. Okay, my 256s, MJ 256, Shakita 256, Janice 256, Jess 256, hi 256, Reset 256. Hi, see, you're not a kid anymore. Hi, good job, 256. Okay, Sirius 256, good. So this gives me 256. Last time I checked, 81 plus 100, that gives me 181. And last time I checked, 181 does not equal 256. So just as someone said earlier, it's not a right triangle. Okay. How did I get 256? 16 times 16. Okay. So I'll put it over here. So you have your 16 times 16. 6 times 6 gives me 36. Carry the 3. 6 times 1 is 6 plus 3 is 9. Then 1 times 6 and 1 times 1. This will give me 6 and 1. Then we're going to add. Bring down our 6. 9 plus 6, that gives me 15. Carry the 1, gives me 2. So that's how we got our 256. I don't want to say pre-algebra. It's a little bit of geometry, a little bit of algebra. Okay. Okay. Please use 0 as a place value holder. How would I know it's not perfect? How will you know it's not perfect? Well, if it's not a number being multiplied by itself, it's not perfect. Okay. So what's the angle? Oh yeah, we're not doing with the angles. Okay. So how would you know it's a right triangle? Well, if both sides are exactly the same. Okay, if both sides are exactly the same. So like if I can use this one that we did, if I take the sum of the squares, so we got our 3 squared plus 4 squared, and I want to know if it equals my other side, which we found was my 5 squared. So 3 squared, that's 9, plus my 4 squared, which is 16. And 9 plus 16, that'll give me 25. And my 5 squared also gives me 25. So when I get the same answer on both sides of the equal sign, that's a right angle. Okay. All right. Okay. So let's try this one. Again, this is human error. I'm just used to just drawing things out. So again, we can use our a squared plus b squared, and we want to see if it equals our c squared. The c squared is always your longest side. So our longest side this time is going to be 20. So we're talking about 20 squared over here. And then these are my 2 legs. They're interchangeable. If you want to say 5 squared plus 14 squared, you can do that. If you want to say 14 squared plus 5 squared, you can do that. So again, we already talked about 5 squared. So 5 squared will give us our 25. What's 14 squared? Okay. So Genesis got my 196 and my 400. 25 and 196 does not equal 400. You got that one, 196. Janice 196. Was that 196? Tyree 196 or Tyree 196. Okay, Michael. Hello, Michael. How was your trip? 196. Thank you so much for the follows, guys. Addicted. Now I know. Okay, 196. All right. And like you guys are saying, your 20 squared, that gives you 400. All right, so last time I checked, 196 plus my 25, that will give me 2, that's 1. Okay, that's 11, that's 12. Carry the 1, that'll be 221. And 221 does not equal 400. So this is not a right triangle. Okay. So if they are equal on both sides, yes, it will be a right triangle. This is for Michael FVD. Okay. Oh, nice. Well, enjoy. Don't get in trouble because I ain't got bail money, all right? All of a sudden be checking a long distance call. I'm like, who's from Vegas? I do not know this person. Okay. So if both sides are exactly the same and they're equal, it will be a right triangle. But since they are not right triangles. They could be acute triangles, they could be obtuse triangles, but they're not right. Okay? They are not right. All right. Okay, well, thank you. Yep, because this is definitely going to be on the T's test. What's the other one? Hesse, sorry. That's going to be on there. GED. These are definitely a 4-point question. And I think a lot of people either skip this because they forget what the formula is. Or they get to a point and they don't know, especially when we get to say here, when they get the 25 equals c squared, they think the answer is 25. And they forget they have to do the square root. So they're getting the answer of c, not c squared. So usually it's like right around here. That's what kind of hurts a couple people in order for them to get that 4-point answer. Okay. All right. All right, good. Okay. How is this problem? All right, so what I'm going to do next is I'm going to tape a couple of word problems. And we're going to see if we can break it down using that Pythagorean theorem. Okay, we can just put it right here. And when they do word problems for the Pythagorean theorem, they usually do either a person flying a kite or a building in a shadow or a ramp. Or what else is the other thing? Oh, and the ladder. They always use like some of those situations. But the results is basically the same. And I might have to move my camera back a little bit so you can see the problem in its entirety. Yep. So I'm going to try to grab as many problems that looks closely to the exam as best I can. I usually get feedback from other people that either passed it or have taken it recently, or a combination of both. They passed it and took it. So let's see. Can we see all of this? All right, it looks like we can. You might have to zoom in on your case, but I'm going to read it. Yep, a stick leaning up against the wall. Yep, there it is, addicted. But right here, we got a ladder. So it says, let me follow along. Remember back in the day, the bouncing ball? But I'm not going to bounce because I know some people are like, I feel nauseous. All right, the bottom of the ladder must be placed 3 feet from the wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? Now, I don't know about you, but I'm a visual person. Okay, so if anything, you can probably, and I'm just going to keep it light and kosher. I'm going to draw, here's my wall. Okay. They said the bottom of the ladder must be 3 feet from the wall. So we're going to say, all right, from here to here. And the ladder, and we all know a ladder when it leans up against the wall. And they just want to know how far up does the ladder touch the wall. So if this is 3 feet, we know the ladder is 12 feet. They want us to figure out what this is from here to here. So now I can write my 90-degree angles right here. And I'm going to zoom in a bit. So right away, I'm noticing that straight across my 90-degree angle, that's going to be my hypotenuse, aka your C value. Okay? These two sides are your two legs. They're interchangeable. One can be A, the other one can be B. It doesn't matter. Okay? It's not going to change their results whatsoever. So let's plug it in. We have our A squared plus B squared equals C squared. So I'm going to put the 3 as the A. Why not? Feeling a little dangerous. Then I have my unknown leg, which is going to be my X. And then my C, my hypotenuse, is going to be 12 squared. So now, this is another part that usually throws people off. Instead of squaring it, they multiply the 3 and the 2. That's not what we're doing. So my exponent is saying I'm multiplying this base to itself 2 times. So that's 3 times 3. 3 times 3, that gives me 9. Bring down my plus sign, bring down my x squared. So now you have your 12 squared. This means 12 times 12. And 12 times 12 gives us 144. Okay, thanks, Sid. Appreciate you. Okay, that's what we're doing. So they're always going to be squared. So now we're going to subtract. So 9 minus 9, that will give me 0, but I don't need that 0 as a placeholder. I bring my x squared equals, and then we want to take my 144, which gives me 135. So that's what my x squared is. Okay, we're not done. Because everyone keeps thinking, oh, okay, the answer is 135. No. Okay. Okay. So we're always going to do the opposite of the square is the square root. And whatever you do on one side of the equation, you have to do on the other side of the equation. So now, the x squared and the square root cancels out. Brings me with my x. And like I said, normally when we're coming out of a square root, we usually do a plus and minus. But we're looking at distance. We're looking at length or height. Okay? So we're only going to be dealing with the positive. But I think 135 can't be broken down. I think that's prime if I'm not mistaken. No, it's not. It can be divisible. It can be divisible. So let me slide over. I had to think for a second. We can break down the square root of 135 into a perfect prime combination. Okay, you're probably thinking, oh, we're done. I'm like, no. Because right now, we have the square root of 135. But I can break that down into 2 radicals. One possibly being a perfect square root. What do we think? Yeah, 5 doesn't work, but it does give me something. My brain had to do this in school. I know, right? So what 2 numbers multiplied together will give me 135? Now, this is the thing the main reason why I designed this notebook. I know, I feel like I'm doing a shameless plug, but hey, this is what I gotta do. In the very back of my notebook, I have factor charts from 1 to 200. So we're looking for the square root of 135. Let's see if I can fit it in here. Okay, so here's 135 right there. So the factors of 135 is 1 and 135, 3 and 45, 5 and 27, and 9 and 15. There we go. Okay, notice 9 and 15 is in red. This is what I call the perfect prime combination. Because square root of 27, I can still break that down with 9 and 3. Okay? Square root of 45, I can still break that down with 5 and 9. But that 9 and 15, that gives me the perfect with the 9, and it gives me that 15 with the prime. Now, you're probably saying, well, Audrey, 15 isn't prime. But when it comes to the world of radicals, it's one of those special prime radicals. Because if you try to break down square root of 15, you're just going to get 5 and 3. And both 5 and 3, they are prime numbers. So we have the square root of 9 and the square root of 15. Square root of 9, again, it's perfect, so it gives me a whole number of 3. And that square root of 15, if I can't break it down, I just simply bring it down. Okay. If they want exact measurements, you're going to be using 3 square root of 15 feet. If they ever say to give us an approximation, now that's going to be tough to do for the GED, the ASVAB, not so much T's, because T's you can use a scientific calculator. Whereas the GED, the ASVAB, ACCUPLACER, you're not allowed to use a calculator unless they're starting to change the rules. But last time I checked about before the summer, no calculator. Okay? So that's why I can't use any decimals right now. Okay, so if they want the approximate or the exact answer, keep it with a radical. If they want the approximate, that means you're going to take your 3 times the square, or you could just straight up take the square root of 135. You don't have to worry about factoring. So if they want the approximate, they usually want you to round either to the 100th position or to the 10th position. Definitely have to check at the question to see what you're going to be rounding to. So let's say they want to round to the 100th position. Okay, so that's where the 1 is located, right here where my pen point is. So that means I need to look in the thousandths to see what I should do if I need to do anything with that 1. So since it has an 8, that means if it's 5 and above, I'm giving a shove. That means I'm going to add 1 to the previous number, which is the 1. So this 1 right here is going to change to a 2 because this number is bigger than 5. So our approximate, which we use an X with the waves, is going to be 11.62 or 11 and 62 hundredths feet. And it's not feet squared because we're not doing the area. Okay, only area we're dealing with squares. So it's just feet. Okay. All right. Yep. Sometimes once you get to a point when you solve, always check your answers. Because sometimes your answers give you a little bit of a clue to especially what you could eliminate. You always should be thinking about the process of elimination. So the process of elimination will help you take down 4 answer choices to possibly 2 or the answer. So always try to do process of elimination. Okay? All right, give me a moment to set up the next one. If there's any questions, please do not hesitate to put it in the chat. Okay, so Damo, go ahead and try to break down the square root of 15. Okay, what two numbers multiply to give you 15 other than 1 and 15? Okay, 3 and 5. Now, is 3 or 5 a perfect square? No. Okay, thank you, Jordan. Okay, 3 and 5 are not perfect squares, so I can't. What do I mean? Is there a number that multiplied by itself to give me 3? Like for me to get a square root of 4, I know I can multiply 2 times 2, because 2 times 2 gives me 4. I know that 9 can be a perfect square root because I know 3 times 3 gives me 9. 4 times 4 gives me 16. 5 times 5 gives me 25. 6 times 6 gives me 36. Okay, so those are called perfect squares. But 3 and, nope, 1 doesn't work. 3 and 5 are not perfect squares. Okay, again with my handy dandy notebook. Okay, here are my squares. Here are my perfect squares. So 1 squared gives me 1, 2 squared gives me 4, 3 squared gives me 9, 4 squared is 16, 5 squared 25, okay? So if I did the square roots of these answers, the 1, 4, 9, 16, 25, 36, it will bring me back to the singular of these numbers. Hence, square roots. Okay. All right. So, in order for you to get the 11.62, we actually had to plug in the square root of 135 into our calculator so we can calculate the square root of that 15 being multiplied by 3. Okay, do you see it now? Because if I can't get one of those perfect squares out of it, can't break it down. So like the square root of 10 is the same thing. You get 5 and 2. Okay, square root of 14, you get the same thing. That's 7 and 2. Okay, so there's a special bunch of prime radicals out there. 7 and 3 with square root of 21. Okay. Yes. The square root of 144 is 12 because 12 times 12 gives me 144. Okay. All right. Okay. Let's get with the next one. In a computer catalog, a computer monitor is listed as being 19 inches. This distance is the diagonal distance across the screen. If the screen measures 10 inches in height, what is the actual width of the screen to the nearest inch? So, just like when we're going TV shopping, when you always hear like a 30-inch TV, and this is what happened. My ex used to deliver TVs and appliances and stuff. And the thing is, there were so many times that they had to take refrigerators, stoves, TVs. They had to take them back to the warehouse because people didn't know how to measure so the things can fit through the door. Yes, it's great that, oh, we have the perfect space for it. It'll fit. But it's something called a door. You do not live in a Barbie dream house that has the opening areas, or you could just open the house up, shove whatever you want to shove in, and then close it. No, you have to measure the doorway. Okay? So many people are like, you got to take off the door off the hinges. People are like lubing up the appliances. It's all kinds of crazy, right? So when we're doing this, we have to measure. And this is a life lesson here. Okay, you have to measure your doorway as well as your space. Okay, please. Now, when it comes to they're using a computer monitor, I can say the same thing for a TV. Okay, when you say that, oh, I want a 72-inch TV, you're not looking at the TV this way. You're looking at the screen on the diagonal. Okay, that's what they're measuring when it comes to TV screens. Same with the monitor screens. Okay, so it's not this way, it's this way. So if we can paint ourselves a picture, all right, so we're saying that the diagonal, like right here, we're saying that this diagonal is 19 inches. Okay. If the screen, the height is in 10, we can measure it this way if we want to. So this is your 10 inches. Keep it clean. Okay, what is the actual width? Okay, this is kind of like how you set it up. If you wanted to put it this way for the 10 and this way for the W, you can do that. Okay, doesn't matter. But here's the thing. They want the actual width. So because they're saying the word actual, they don't want a decimal place. They want to know what the radical, if there is a radical. So what we're doing is Pythagorean's Theorem. Okay, so now we have our a squared plus b squared equals c squared. You took part of the fridge last week? Yeah. Exactly. All right. So again, the side that is directly across from that 90-degree angle, that's always going to be your C. So my C in this case is going to be 19, and we're going to square it. Got my equals. So now we have our two legs. It doesn't matter which is which. So if I want, I can make this W squared plus 10 squared. All right, so let's do some calculations. So we have our W squared, that's what we're looking for, plus 10 squared, okay? For right triangles, yes, demo. Yep. And we're lucky that most of our stuff that we have in our facilities, it can be formed as a right triangle. Anything that gives you a 90-degree angle, you can convert it into like, oh, right triangles. All right. 19 squared. What do we think? And don't say 38. I'm like getting all threatening and over here. Do not say 38. 19 squared. 19 times 19. Okay, Brianna's saying 361. Jenna is saying 361. Kevin, 361. Oh, welcome back, Kevin. Okay, 1446. Ray, ditto, saying 361. So many numbers with you. Okay, Malik, 361. Good. Thanks so much for the follow. Is that 361? Okay, we got our answer. Felix is 361. Okay, the answer is 16 squared. Well, let's see. All right, well, thank you, mathematics fan. Appreciate it. Okay, so right here, got our 361. All right, so what do we do next? Yep, the answer has to be in inches. Correct. Thank you for pointing that out. Because these exams, they will have you do some conversion at times. They might say, well, how many feet? And then you have to know how to convert your inches to feet. 12 inches in 1 foot. So you might have to do some multiplying of 12. But always take a look. Good job, guys. We're going to subtract that 100 on both sides. Excellent. Okay, so positive 100 minus 100, that gives me 0. Don't need that placeholder 0 because I still have my w squared, which is going to equal my 261. So now, let's see, what should I do? Is it exactly 16 inches, Blue Beauty? For 261, we have to find that square root. There we go. We got to get rid of our square. So if we do the square root of both sides, okay, the square and the square root cancels out. So that's why we're able to bring our w down. Now, the square root of 261. Okay, and we want the exact. Okay, so that's rounded. That's the estimating. Okay, so it's not exactly 16. Okay, it's definitely not 16. Because 16 squared, what we got? 16 squared is 256. I had to think for a second. Okay. Ooh. So we're saying that 261... if we divide it by 9, we will get our 29. Look at Janice go. Love it. So we got our 261. Oops. So if I break that down into a perfect prime combination, it's always good. So go ahead, divide it by your perfects. And then we get a 29. 29, that's definitely a prime number. So square root of 9, that gives us 3. And that square root of 29, if I can't break it down, I'm bringing it down. Look at Janice go. Go ahead, girl. Okay, so the exact width is going to be 3 and 29, the square root of 29 inches. Not inches squared, just inches. Okay, the only time you're squaring it is when you're finding area. I think that's the easiest way for you to remember. Okay. All right. Okay, how are we feeling? Yeah. Add the digits. That's a 9. 9 is a factor. Yep, that's true, Michael. Well, anytime they're saying that it's the diagonal distance, that's how I knew that that was going to be RC. Okay, because it said the diagonal distance. Okay, you're so welcome. Okay, hey, that's fine, Joe. As long as you start somewhere, that's fine. I always say, look, we are no longer the shy kid in our math class like we were when we were younger. Okay? We have evolved. All right, let's hit with one more. just realized this thing is like twisted. I'm over here playing Twister. I was like, why am I so like twisted up? Okay. Okay, so for my geometry people, this one is for you. But it would also be on your TEAS test, ASVAB, ACCUPLACER, all of that. And the reason why I don't pre-tape, because sometimes I don't know how much room I'm gonna have or how much room you guys need. So I'm so sorry that I'm taking up a little bit of time. All right, let's see what we got here. All right, awesome. Read the last 4 words of the question. Okay. Okay. But the whole thing, it says actual. Now, that's the reason why I'm not putting it as decimals. Now, here's my thing. If I look at my answer choices and I do see decimals, yeah. But here's my thing. How? And I'm just thinking from like a GED, like a assessed area, and not so much a classroom. Because I know the classroom, you will allow people to use a calculator. But I'm thinking about those people that can't use a calculator. How are they going to calculate the square root of 29? So I get it, but that's where I'm coming from. Okay? That's where I'm coming from, Greg. So I get what you're saying. I'm not saying that you're wrong. But I'm just saying, like, from a tested area, that's how they're going to stop it. Okay. Okay. All right. Sure. This last one? Yeah, addicted. You guys can solve. The ones I was going to let you guys go do it anyway. Okay. 20 what? Addicted. Okay. Yep, you can plug in for A or B. There you go, Greg. There was just something missing, addictive. What did you miss? A lot. All right, Brianna. There you go, Dill. There it is. Okay. Why was I waiting for a comment like that, Michael? I love thick sauce. What did you miss? A lot. Yeah, we're on our final question. All right, so rectangle. We know with a rectangle, all four angles is 90 degrees. They're saying that the diagonal of my rectangle is 25. I don't even need the whole entire thing. I just need one of my triangles, okay? So they're saying that my width is 15 inches. So they want their length. So we can say this is 15 inches. I almost forgot the inches. And this is my unknown. So we're going right into Pythagorean Theorem. You got your legs and your hypotenuse. My hypotenuse is going to be the diagonal. So we got our 25 squared. Then we can say our x squared plus our 15 squared. So we got our x squared plus my 15 squared, 15, 15, 225. And then we have our 625. Excuse me. So then we have our 625, that 25. That gives me my subtracting my 225. So we have our x squared is equal to 400. Then once we take the square root of both sides, we get x is equal to 20. And I know we're going to have the urge of saying plus or minus 20, but since we're looking at length, it's going to be 20 inches. So sometimes if you need to draw yourself a picture, just this little sketch. I'm a visual person, so the sketch kind of helps me a little bit. But understanding Pythagorean Theorem, which is your a squared plus b squared equals c squared. If they ever give you the diagonal of anything, the diagonal of a TV set, the diagonal of a computer monitor, or just say the diagonal of a rectangle, that's going to be your c. All right, the other two legs are interchangeable for your A and your B. Okay, key thing, make sure you understand the square, and then when you get to this part, make sure you do the square root. Because trust me, 400 will be one of your solutions on those assessments. They're diabolical. They will do that. Okay, all right. Yup, book 6 is almost done. It probably might be done this week, actually, because we don't have that much left. Probably like what? How many more sessions? 1, 2, 3, 4, like 6 more sessions? All right, not too shabby. So it should be done like sometime this week, maybe Saturday, and then I'll upload it. Yep, so it's going to be happening. Right, so you need to have at least one or the other. Yeah, you can't. You have to have a length or a width. Okay. All right, so as I mentioned before, I designed this notebook right here. So if you're interested, this is the actual notes that I do here on TikTok. And, excuse me. So for me, it's usually like a blank sheet on one side and then grid on the other side. Just something to help organize people's notes. Gives you a section for formula, for steps. But not only does it have the factor chart, it also has like different words and phrases. Also the squares and the cubes to help you, going all the way up to 15. The rules of integers, some inequalities, interval notation, order of operations, exponents, linear. We actually worked on quadratics. Then you have fraction operations, decimal operations. And this is a lot of things to remind you, especially give you the formulas. And then here's system of equations. And then also volume, surface area. Hey, this looks familiar. Pythagorean Theorem, a little bit of trig, and also area and perimeter, or circumference if you're working with circles. So I usually have this one is going to be for my Algebra 1, pre-algebra, Algebra 1 type students. Then I have, which it finally came in, okay, making its premiere. This is the one for Algebra 2 and pre-calculus. Same setup as the other ones, but the only thing is the resources is slightly different. Okay, we still have the factor sheet. This time we're talking about complex numbers. Okay, you have the conversion part of it. Then we have, those are similar, these are similar. Arithmetic and geometric is similar. Then we get into logs and exponentials. That's different. Then we have our acceleration, time, change in velocity. We have that in there. Also, we have our conic sections and their formulas, and the famous unit circle, okay, with all of its flair. And okay, we do a little bit of the sine and the cosine, even having their particular waves and their domains and the general equations, and how to basically write up the sine and cosine waves, and also the sine and cosines. Then you also have your trig identities, which help you break down our concepts. And last but not least, the Pascal triangle. Okay, so just for those little reminders to kind of help you to go from one step to the next that you really generally see. Now, if you are left-handed, I do have you guys covered. This is the left-handed edition of the pre-algebra and the Algebra 1. So truly left-handed, be able for you to keep your notes together and no more reaching over and just getting all kinds of crazy. You can write your notes this way and you'll be perfectly fine on the other side. All right, so if you want a copy of my notes, okay, all the notes that you've seen that are done, I have what's called Audrey's notes. Now with Audrey's notes, it's just a scanned copy. Notice in the back, you do not get the resources, okay? It's just a copy of my notes. And what happens, if you notice here, they all have a QR code. And the QR code will take you directly to the TikTok Live, okay? Then you can follow along. You can use this for mediation. You can use it for initial learning, okay? And right now we're on book number 6, but books 1 through 5 is ready, available for purchase, okay? So if you want to purchase my notes, you can do that. And all of my notes and all of my books are on sale until tomorrow. Tomorrow's the last day? Hold on. Yep, tomorrow is the last day of the month. And it'll be at $10.29. And the price is definitely going to go up October the 1st. Okay? So if you're interested, you can do that. Again, you can hit that Service Plus. If you want any information about me, about my service, my tutoring service, because I do tutor up to college algebra. So anyone taking those intermediate classes or college algebra, I can help you. Calculus, not my jam. Statistics, I'll do it, but I'm not in love with it. Okay? Hey, burly boy. Oh, that's all right. Okay. So is this college level? Yep, I just go all the way up to pre-calculus. All right. But if you have any questions whatsoever, please do not hesitate. I'd rather you ask a question before you just go ahead and straight purchase stuff. Okay, because I don't want to just take your money. I really want you to use these services to help you for whatever your next step in life is. So even if you're currently taking a class and you just need some assistance, I'd rather you do that than nothing at all. Now, one last thing. So if you came late and you're like, oh, I wish I was here for the whole thing, look at this. All I can do is point, because everybody TikTok's been giving me tons of violations lately. I'm not doing anything. I think it's just because it's me. All right. So go ahead and screenshot it. I'm going to take it down in 5, 4, 3, 2, 1. So give me a moment. I know the month flew by. Give me a moment to upload it. And if you do need any tutoring for you, little brother, son, daughter, okay, right now, September is starting to fill up, which I'm excited about. Okay, if you're interested in courses, I have courses that I generally make. It's 107 videos, and it also comes with practice problems and quizzes. So if you're interested, you can go here to take a look at that. But all of this, if you just, visit the profile, that'll be perfectly fine. Okay. All right. Thank you so much. Well, thanks, Janice. Appreciate you. All right. So if you need anything, please, please, please do not hesitate. Stop trying to suffer in silence. It's over. Okay. You got someone that's going to be here to support you to the best of my ability. If it's not me, I have friends that do tutoring, and some of them are here on TikTok and some of them are not. But I only associate with some awesome people. So if that's what you need, please do not hesitate whatsoever to DM me. And I think that's about it. Okay. I'm glad you like Math League. Hopefully today's session was very useful to you. And if so, great. So I will definitely see you guys tomorrow evening at 6:30 again. We're going to see if we can get a little bit of some SAT or some PSAT help. Just like some general review. Okay, so I'm just going to have a couple problems on here. You guys are going to try to work it out, and then I'll sit here and explain or actually show you how you can get your answer a little bit faster. All right? Alrighty. Have a lovely evening. Don't scroll too much. Be safe. Again, I'm serious. I do not have bail money, so just keep it clean. Okay? All right. Is this math at the what? I'm not sure what that is. All right. Peace out, guys. Bye.